Let's look at another technique which would represent the boosting family. So under ensemble modeling, we've already seen an example for bagging, which is random forest. Let's have a look at one technique which will fall into the boosting category. So we have another very popular algorithm called as XGBoosting. Now XGBoosting is one of the most well-performing large-scale scalable machine learning algorithms. It is developed on the principles of boosting and ensemble modeling. Now we already know what's boosting. It's a process where models are sequentially built and each new model learns from the residue of the previous model. What can we do with XGBoosting? Like random forest, we can do classification as well as regression for boosting, XGBoosting. Now we come to a very important question. How is XGBoosting different? So like you have AdaBoost, you have gradient distributions, you have a variety of different techniques under boosting. But then what is essentially different in XGBoosting that kind of made it extremely popular? So first of all, as we discussed, random forest is blazingly fast because each of these trees have no connection with each other. They can develop themselves in parallel. So you can leverage parallel processing and the process can finish pretty fast. So if you have a really powerful system, let's say a quad core engine, so you can leverage a model on each of the cores and process in parallel. So it saves a lot of time. But then boosting techniques are kind of very slow because the process is kind of sequential. You can't really leverage parallel processing over here. So in XGBoosting, there is an alternative way through which you can parallelize a couple of things. You can't definitely uh, implement complete parallel processing, but in certain parts which don't really have dependency on each other, kind of work in parallel, that improves the processing power, processing speed. So to a certain extent, it implements parallel processing. That's the first USP of XGBoosting. Second, and the biggest USP, is it controls overfitting by regularization. Now, even though XGBoosting is actually a technique used, boosting is a technique used when you have underfitting. So when you have underfitting, it's a scenario where you have a model which performs bad on your training dataset as well as your test dataset. So you kind of boost each model. One model learns from the residue of previous model, and the process kind of creates a powerful learner. But unfortunately, in most cases, when you iterate from one model to another model, in the process of learning from the errors the previous model has made, it kind of builds unnecessarily complicated models and it tends to overfit. So from an underfitting scenario, it kind of gets to an overfitting scenario and it doesn't really help. So most of these boosting techniques were really hard to tune. So if you talk about random forest, it's very easy to actually get a good like a very accurate model with easy steps. But that was not the case with boosting. Boosting kind of required a lot of efforts, a lot of hidden tries to actually hit the sweet spot. And it was kind of difficult to actually avoid overfitting. So over a process of let's say 25 trees, 25 iterations, you kind of hit that saturation point where you kind of overfit and you don't really know how to tune your parameters. So XGBoosting controls overfitting by regularization. It is one of the first boosting techniques that kind of implemented regularization within the technique. So that helped not overfit not overfit the model and have a kind of generalized yet powerful technique. So generally you would use boosting in a scenario where you have underfitting models that and then XGBoosting is that specific model which will implement regularization within the modeling technique and then help you build robust models and get better accuracy. So that's a bit about XGBoosting. It's now time that we implement a basic example of XGBoosting as well as random forest in the Python ecosystem. Let's get started.